This podcast is sponsored by the Red Hat Developer Program. Download our latest O'Reilly book, Building Reactive Microservices in Java. Learn why Eclipse Vertex is a good choice to build effective microservice systems. Download it now at infoq.link/Red Hat.
Hello and welcome to the InfoQ podcast. My name is Wes Rice and I'm your host. In addition to hosting the InfoQ podcast, I get the crazy privilege to host a set of software conferences called QCon. QCon is a software conference focused on architects, senior developers, technical engineering managers, and tech leads. We focus on the real-world problems you face building apps. It's conversations with people building them. It's networking with other software leaders like you. The next QCon is in London, March 5th through 7th. I hope you can join us. On today's podcast, I'm talking to Kolton Andrus. This is actually the second time this year I've spoke to Kolton. The first time around, the company that he's the CEO of, Gremlin Inc., was in an early alpha stage. So he was exploring products, working with some customers, finding the right market fit. That product has matured, and he had a recent announcement that I have invited him back to talk a bit about. Gremlin itself is a software as a service that lets you plan, control, contain, and undo chaos experiments, and it's built by engineers with experience in Netflix, AWS, Dropbox, and even the RSA. On today's podcast, we talk about what Gremlin's been up to, including this big recent news from Gremlin. We talk about setting up game days with Gremlin, what that looks like, where Gremlin fits into the bigger scheme of things. Then we wrap with some of the architecture on Gremlin. So I hope you enjoy the podcast. It's always fun to talk to Kolton. Kolton, welcome to the InfoQ podcast.
Thanks for having me, Wes. It's always a pleasure to be here.
I said there's this big news. Let's go ahead and just jump right out. What's the big news?
Yeah, so yesterday was our big launch day. We had the opportunity to publicly speak about all of the great things that we've been doing and the successes we have. Gremlin as a product, our failure as a service or resilience as a service, as we're calling it now, is now publicly available. We think it's enterprise ready. We have some of our early customers that are using it in production, and we're able to speak about a couple of them now, including Twilio and Expedia, Confluent, and Remind. We're also super excited to announce our funding. We closed our Series A round earlier this year. It was $7.5 million from Amplify Partners and Index Ventures. And yeah, we're excited to kind of let the world know about Gremlin and teach everyone about this new discipline of chaos engineering.
So now I know we got all kinds of enterprising startups that are listening to this, I'm sure. So what is it like to come up with this idea and then go through launch day? What was that like?
It was a big day. We've been preparing for it for weeks and months, trying to get everything ready and lined up. And then, it's a bit anticlimactic. We watch everything, blow up on social media. We see some news articles come out, we pop a little champagne in the office, and then we're all tired and we go home at the end of the day.
Yeah, that's awesome. Well, congrats on the Series A and congrats on Gremlin. It's awesome to see everything kind of come full circle with this. It's awesome.
Thank you.
So let's start off. You just said something as you were talking that kind of stuck with me. So I'm used to hearing failure as a service from you. You said resilience as a service. Why the change? Why failure versus resilience?
Yeah, so I think failure as a service resonates well with the engineers, and it's a little punchy. It talks about what we're trying to do, this idea of breaking things on purpose. But that's really not the business we're in. That's the means to an end. What we're really focused on is helping companies build more resilient software. Our mission and our vision at Gremlin is to make the internet more reliable. We live in a time and a place where we all rely on the internet, whether it's education, whether it's communication, whether it's travel, whether it's health. Things when it goes down and it breaks, it has a real impact to everybody. And so we really want to just help make things stronger, better. Imagine what the internet will look like in 100 years. Well, we think this is the path to get there.
It's actually injecting a little bit of pain. I think you used the word inoculation when we talked before. It's injecting a little bit so that way you're more prepared for the big events that might come.
Exactly. The vaccine analogy or the flu shot, we're gonna cause these little bits of harm that are gonna happen naturally anyway, but that's gonna help us test and validate our defenses and make those non-events.
So I guess we should level set. We kind of dove right in. We're talking about chaos engineering. Gremlin is a product that was one of the first that I know of that is software as a service around the idea of chaos engineering. But let's start off. Define chaos engineering. What is it? Why do I care?
Yeah, I've got a little bit of a different definition of chaos engineering than other people. The thing I like to focus on is that it's really about these thoughtful, planned experiments that teach us about how the system behaves when things go wrong. So one thing I'll throw out there just to start, we love Chaos Monkey. It was a pioneer. It did a lot of value. But because of Chaos Monkey, a lot of people think that the only way to do chaos engineering is to randomly break stuff. And we disagree with that. We don't think that's the right place to start. And we think, again, these thoughtful, planned experiments are much better, both at revealing where the system is weak, but also allowing you to train your teams, their operational processes, the on call, that whole process as well. Because, as is said in many places, it's not just the tech, it's the people and how it all fits together that really defines the system.
Sure, totally. So let's talk about that. Thoughtful planned experiments. What is a thoughtful planned experiment in the area with chaos engineering?
Yeah, so maybe this is a great time to kind of talk about what a game day is, because this is one of the things that we're doing a lot with our early customers. So this idea of a game day, we want to get a group of engineers in a room, and we want to think about what could go wrong. One of the first steps here, and you get a lot of the value by just stepping back and asking, "Hey, what could go wrong?" And so we have engineers whiteboard out their service, and then we'll iterate on it. Usually the first pass doesn't have all of the external dependencies. Oh, are you storing config in S3, or are you using an online database? And so once we've really drawn out all of the network connections, all of the ways in which the service fits together, that's when it's time to run the experiments. So from that diagram, we form these hypotheses. How do we think the system will behave if this fails or if this service goes away? And really, again, that's a very valuable part of it. Just knowing what could go wrong and what you think will happen, it reveals a lot. And then the next step is to be able to go execute that experiment. And so what we do at Gremlin is we provide the tooling, we help with that thinking through the game day and planning it, but then we let the engineers drive. They know their services, they're the experts. They go out, they run the experiment. We're there to answer questions and help, but then we see what really happens. And oftentimes what we see is that our assumptions were incorrect or incomplete, and there's some subtleties in how the system behaves.
So an example might be the hard drive fills up with log files. What happens, right? So you plan a specific test that says, okay, if I max out the physical storage that's on the box, what's going to happen? What would an experiment look like wrapped around the idea of log files?
I mean, so that one in particular you mentioned, we wrote a blog post about that because we got burned by that. So early, a couple of months back, we had some logs that weren't rotating appropriately. We filled up space on a disk and it caused failures. And so we actually wrote a whole blog post about first, oh, we got burned by this. We don't ever want to get burned by this again. We're going to practice what we preach. Let's go run a game day. Let's fill up our disks. Okay, what are we missing in order to make sure these files are rotating or we're getting alerting or, things can continue to operate if that happens. And then we tested it.
What does that look like? I mean, so I'm assuming this is, you have multiple instances here. Do you split it off? Do you do a blue-green deployment where you've got multiple instances running? Do you break off a canary that has some traffic? How do you actually do the experiment?
Yeah, so I think there's a couple of ways that this can be done. What we advocate is this concept of the blast radius. What you want to do when you're planning these experiments is you want to start with the smallest thing that will teach you something meaningful about your system. If that's a single host, if it's a single container, in the Lambda world, it might be a single function. Like, what's the minimum thing you can do to learn about it? And then you test that assumption. And the nice thing is if things break there or if things go wrong, that cost of being wrong is low. If you break a single instance, hopefully that's not going to bring down your whole system, whether you're in staging or in production. And then once you see how it behaves and you build that trust and confidence in your system, you increase the blast radius. So it's kind of this workflow, think about what could go wrong, plan the experiment. Step one, run the smallest one that'll teach you something. If that fails, cool, you're done. You just found a bug, you found a problem, you go fix it. If it doesn't fail, if it works as you expected, now you scale it up. Now we run it for 2 or 3 instances. Now we run it for a whole service until we're running in the entirety of our environment. And one thing I'll mention, a lot of people tend to start and test or stage. They build up their confidence there. And so if you make that jump into production, you reset the blast radius. You go back to the smallest impact possible and you grow it again.
Yeah, it's as you're talking there, the thing that comes to mind is the never fail the same way twice type mentality. So you test something, see how it fails, fix it so you don't fail that way again. That makes total sense to me.
Well, and then the last step. So fix it so it never fails again. There's something implicit at the end there, which is some testing or some automation that prevents that reoccurrence. And so what we advocate is you run this experiment, you build your confidence, it behaves the way you expect, and then you automate it. Whether it's random, whether it's scheduled, whether it's part of your continuous deployment pipeline, you then regularly exercise that failure so you remain resilient to it.
We talked a bit about what this idea of chaos engineering is, and we talked about some key concepts like blast radius, and we gave an example like log files filling up of something that you might actually test to. I want to actually talk about Gremlin now, and I don't normally talk about products specifically, but this is the first that I'm aware of. Are there any other products out there that are like Gremlin?
I think there's a lot of kind of open source projects that are in varying stages of maturity. But in terms of, an enterprise offering, something that really people are comfortable running in production, we think we're the only one. If you know of another, let me know.
I don't know of any, but I'll tell you, to get set up for this podcast, I wanted to actually kind of to feel it out, to see what Gremlin was like. So literally in the space of about 40 minutes, I built up a parse server that was on AWS, just a single instance, not a whole cluster or anything. I set up Gremlin, I installed the agents, and I filled up a log file. I use that exact example. I filled up the system, and I got a 503. So within the span of really like 40 minutes, 30 minutes maybe, I was able to get it up and running. So that was pretty cool. Congrats on that.
Thanks. Simplicity is one of our key tenets. Like, it should be easy to do. If you want engineers to do the right thing, you got to make it easy. You said 40. I want that to be 5 or 10. I'll follow up with you afterwards, see how to make that better.
It was probably all me, not you. I was also, one of the other things about it, I was pretty impressed that it was a very simple, you mentioned simplicity. The interface was pretty simple. It was very focused. There wasn't a lot of feature overload with it. That was pretty cool. So let's talk a bit about how Gremlin actually fits into this idea of a game day. What does Gremlin itself give a software developer?
Yeah, so Gremlin is that tooling. So in that game day process, obviously the teams, the engineers, they bring the expertise. They know the systems. They know how it should behave. But then when it comes to wanting to quickly and easily run these experiments, Gremlin is that platform that really just makes it dead simple to run it and safe to run it. One of the things that we're really proud of, and one of the things that we think open source has a little bit to catch up on, is this concept of safety. It's a bit of a scary topic to some people, and so having an undo button if things go wrong, just a way to say, oops, I ran this too big, or hey, this is having more of an impact than I thought, or I'm done and I've learned what I needed to. Just having that ability to click that and say we're done is super powerful.
What does that mean? So I use this log. We'll talk about some of the other ones in a minute, but I use this log example, filling up the hard drive. What does it mean to say undo once you've already maxed out or filled up the hard drive?
Yeah, so each Gremlin, that means something different for every failure mode, right? And so we've been very thoughtful about how to build Gremlins in a reversible fashion. So for the disk one, you tell us where to write the file and you handle the file permissions. But if at any point you undo it, we're going to clean up that file. And we also make some additional guarantees because of the way that the Gremlin control plane and the system is built. If we were to fail, or if the experiment, something was to go functionally wrong with the experiment, we'd automatically halt it. We'd automatically clean it up after ourselves. If you want to take like another example, the CPU Gremlin, you're just consuming a lot of resources. So at that point, if you want to roll it back, you're just killing that process. You're saying, get out of here, stop being noisy. Other ones are a bit more tricky. For a fun, take-home exercise, we do a time travel one where we modify time on the box. So one, being able to make sure that Gremlin's agent handled time changing correctly took us a little bit of time and was fun. But then building it so that you can revert it back at any point and time is correct, because system correctness is key. That took a little bit of work to get it right.
So let's talk a bit about the different types of Gremlins that you can actually inject. You've mentioned CPU, we've talked about file. the actual file system itself, filling it up. You talked about time travel. There's 3 different categories and a variety of different ones. What are some of the things that Gremlin can do?
Yeah, so we have these 3 top level categories: things that consume resources, things that change the state of the host or the VM, and things that change the network. So the resource ones, that's like, cool, we want to max out CPU, we want to take up and hold on to a bunch of memory, we want to eat up a lot of disk space, or we want to introduce a lot of IO overhead on a mount point or a drive. The state ones, those are fun. One of them's process killer, so kind of like P killer in a box. We want to just be able to kill processes or consistently kill processes and see how the system recovers. We mentioned time travel. So what happens when daylight savings occurs? What happens when there's a leap second? What happens when one of your hosts is in clock skew and has a different time from everyone else? We make it easy to test that. And then the other one on the state level is rebooting a host or a container. And so, being able to shut down and reboot hosts and containers, just like we saw with Chaos Monkey, remains a valuable, interesting test for people to run. And then the network ones, those are, I kind of think, the bread and butter. We're living in a distributed systems world where everyone's moving to microservices. And now, that old joke, someone's service over there can break mine, is true all the more often. And so what happens when we can't resolve DNS, similar to the Dyn outage that happened last fall? What happens when we can't talk to a service, when that service gets slow, or that service is experiencing a lot of packet loss or packet corruption or reordering? And we make those network attacks very easy to scope, to be able to say, look, I only want to impact traffic to www.google.com. Or, hey, we know a little bit about Amazon's infrastructure. I only want to fail S3 in US East 1. Show me how my system behaves when that happens.
So tell me something. So you talked a bit about safety earlier, and you talked about undo, and then you just mentioned about like limiting it towards domains or particular regions with S3. How do you maintain that blast radius with Gremlin? How do you make it safe that it's not going to impact other areas? Is that part of Gremlin's kind of purview, or is that how the app is built?
I mean, that's a little bit of how you do chaos engineering properly, and a little bit of the tooling we built into Gremlin. Again, it's a bit of a process approach where you want to start small and increase that blast radius. We make it very easy within the Gremlin tool to filter and to select subsets of hosts you want to experiment on. Things like show me all the hosts in this zone, or show me all the hosts in this service. And so that's some of the ways that we help in scoping that blast radius. I think, to be honest, we have more to do there. We want to make it we want those guardrails so that people feel comfortable when they're just getting started.
When I went through the process, I set it up, I installed the agent on an individual instance. If I've got hundreds, how do you deal with like fleets of machines? How do you handle that scenario?
Yeah, so certainly that's something that we prepared for from the beginning. When we built this at Amazon and at Netflix, obviously there were hundreds and thousands of hosts that were using it. And so we've made it very easy to automate the deployment of Gremlin. We've given all of the right hooks for tagging, for authentication. Again, we do a lot of dog fooding at Gremlin, and so we automate our own deployment of Gremlin on our services. And then, of course, we run our own game days and we break our own stuff. But we've really built it to be able so that however you manage your infrastructure, Gremlin fits in seamlessly.
You also have a rich set of APIs that you can use as well, right? What's the use case for these APIs?
Yeah, I mean, again, being a developer-focused company, we actually built the command line interface first. And you may not have played with that, but that's pretty and polished and works fine. We built the API second, and we built the web interface third. And so everything that you can do in our web interface goes through our API. We don't circumvent it anyway. So basically, we expose programmatic access to everything that Gremlin can do. And we think that's key because again, you may want to do some of this manual testing and exploration using the web interface, but we know you're going to want to automate it and you're going to want to be able to run this programmatically in the long run. So our API is definitely a first-class citizen.
So what are you seeing with some of the early alpha customers? What experiences have they had?
Yeah, we've had a lot of great experiences. It's been great to just see the interest in the industry as a whole. You might be surprised, but all the big banks, all the big e-commerce sites, even companies that aren't classically tech focused are coming and talking to us. Chaos engineering is on their radar, and it's something they're gonna do in 2018 with or without us. a lot of the value we've seen in the beginning is just about saving engineers time. We met with one of our customers, Confluent, and we ran a game day with them. They had done it by hand earlier that week. It took their whole team an entire day to run through this set of failure tests they wanted to run through. We showed up and we ran the game day in 2 hours, and we were able to get through everything that they got through on that other day and more.
I think at QCon SF this past November that just finished, you had Expedia as well that talked a bit about what their experience was with Gremlin, right?
Yeah, it was great to have them on our track. And I would say just a pitch for QCon here. If you want to learn more, the Art of Chaos Engineering track that just happened was great. We had many great speakers ranging from we're beginners and we're starting to we're experts and this is how you should do it. Expedia in particular, they spoke about how Gremlin in the beginning was very exploratory. They wanted to use it to understand how the system behaved, to get that feeling and that confidence that things were working the way they expected. And now they're moving into doing more automated testing and making it a regular part of their process. They also talked a little bit about, I thought they had some great content in there on scorecards and on maturity, on readiness of teams. And really, because again, it's one part tooling, but it's one part teaching. And they're playing this game where they need to go and educate an organization about how to do this the right way. And we've been excited to partner with them and help them, in their journey in that space.
That's awesome. And that was not a planted pitch about QCon, or maybe it was, I'm not sure.
Well, it's a planted pitch for me. I hosted the track. I'm very proud of the speakers and how it went. So I'm wearing my QCon shirt today. I'm representing. I know those at home don't get to see it, but I'm a fan.
One other question that I wanted to ask you is that all the systems that we see today seem to be leveraging containers. What's the story around containers and maybe like orchestrators and service discovery and different things that you have to solve when you're dealing with containers and something like Kubernetes?
Yeah, what's interesting is we built Gremlin using containers from the beginning, and we did a lot of our own testing just out of convenience. But it was very clear a year and a half ago that we needed to support containers as first-class citizens. So a couple of the ways that we've done that. We built Gremlin so that you can deploy it as a Debian, as an RPM package, or as a container. And if you deploy it as a container, you can either attack that root host, or you can target and attack the containers that are running on that host. So the ability to be able to run an attack on a host, but only impact containers that match labels foo or bar, or that only match service equals X. Again, that's about that blast radius. It's about supporting the tooling that people are using, which is super important. And Kubernetes and ECS on the new Amazon service, we test with all of those. Those are important to us. But that ability to break that failure testing down into that finer granularity is powerful.
How is this playing with cloud providers? So I used it on AWS, had no issues, whatever. What about other providers? Any issues, or it works seamlessly with all the different cloud providers out there? Any issues there?
This is a place, thanks for the opportunity, to talk about one of our strengths. So Gremlin is built to run on Linux. We don't care where you're running. We can run on your bare metal hardware in the data center. We can run on Amazon, on Azure, on Google, wherever you want to deploy. If you're on some of the cloud providers, we have some nice to haves. We know a little bit about Amazon services. And so we can help you run some attacks against those out of the gate. But really, we think of this as a nice solution that bridges the gap as teams are moving from the cloud, being able to test both sides of that migration to see if they're really ready and if they, see what happens when they turn off the data center.
One last question before we switch over into more of the architecture of the app. Is this safe for production?
Yeah, so one thing we run into a lot is engineers pretty quickly when we're talking to them, they're like, yeah, we want this. This looks awesome. This is what we're interested in. But we don't think our security team is going to be okay with this. And so that's another one of our core tenets. We've talked about our core tenets, safety, security, and simplicity. But security is a first-class citizen at Gremlin. And again, not to dog on open source, but I think this is a problem that open source kind of delegates to the reader as an exercise. So we've done a few things. We don't run Gremlin as root. We follow least permissions everywhere. When we communicate with our control plane, we do it via outbound communication over secure channels. So there's no opening ports in your firewall or worrying about things getting pushed into your environment. Our security engineers, XRSA, super sharp fellow. We've engaged with third parties to pen test our environment, our website, our service, our client, our infrastructure to make sure that we're following best practices. And then this summer, part of what we needed to do before launch is build in these last key enterprise security features: single sign-on, SAML 2.0, multi-factor authentication, role-based access control, auditing. And so we think those are super important. And we're proud that we've talked to many internet scale, publicly traded companies' security teams, and they're comfortable with what we're doing with Gremlin.
So that is, yes, it's safe for production.
Yes.
Very nice. Okay, so let's talk about, how do you build this? How do you build a Gremlin? What's the components? What's the widgets?
Yeah, so I'll just take a moment here and pitch Rust. Rust is the language we chose to write the client in, and it's been amazing. Rust treats failure as a first-class citizen, so right there we're ideologically aligned. But if you're writing something that you want to be performant, low level, be able to impact the network, in my opinion, I love C, I don't love C++. Rust really takes everything that's been learned in the last 10 or 20 years of programming languages and builds a better language.
So you weren't doing Rust before. What was your learning curve with adopting Rust?
Yeah, Rust was new to us, and it's been new for every team member that's joined. Matt and I, my co-founder, the first 3 months of the company, we're spending time ramping up on Rust and learning it. But we were able to hit our stride fairly quickly. One of our rites of passage whenever a new team member joins is to have them write a new Gremlin, a new failure mode. And we've actually found that to be a feature. People love to learn a new language. They've loved to play with Rust. Usually, I think everyone on our team is converted and fans.
What are some of the big features that sold you on Rust?
So Rust does deterministic memory management. So your garbage collection's happening, but it's happening at bounds that are known. So you get a very consistent, performant overall profile. As I mentioned, failure is a first-class citizen in Rust. So rather than like the C convention of returning a -1 or throw a Java conception of throwing an exception, the signatures within Rust have a result, which is either things went well or here was your failure. And so that allowed us to just be very thoughtful. When things failed, we had to handle it. And the compiler does a great job of kind of checking you and kicking your butt in the beginning, but really making it safe so that you're not doing things that you would rather not do.
So, okay, that's the client. That's the thing that's installed on each one of the machines that communicates back, that can actually deal with the, filling up the drive and maxing out CPU, those different gremlins that you might put in. What's the rest? What's the web tier? What's the cloud? How it communicates, those kind of things?
Yeah, so we wrote the service in Java running on AWS, kind of your classic, just like we would have built at Amazon or Netflix. I don't think there's anything super fancy there. We're using some Amazon services under the cover, which we've gone and failure tested. So we know that we handle those failures well. The web interface is written in Ember. It's something that I used at Netflix. And so it was something that was kind of easy to get started with. We're actually kind of evaluating right now if we're going to stick with Ember or move into more of a React focus. Finding good talent and finding people in the Ember world has become a little rough. So we're giving some thought there.
What about communication between the client? How does that work?
Yeah, so as I mentioned, the client polls to the service, outbound SSL connection, and where it essentially says, hey, do you have work for me to do? Or this is what I'm doing. Is that okay? Do you want me to halt? And that gives us that nice touch point where if we ever lose communication with the service, then we know that something's gone wrong and we can halt that attack. We can roll it back and fall back to steady state.
Any other interesting bits in the architecture?
I imagine we can have this conversation in a year and our architecture will be much more complicated. Right now, we're believers in the simplest thing that'll work.
Nothing wrong with simplicity. I'm just curious.
Yeah, absolutely.
All these different instances that are coming in, what's the scalability of it look like?
Yeah, so we, again, in that spirit of dog fooding, or as Jeff from Amazon said, drinking our own champagne, we do regular game days and we do regular load tests. So before we even did our beta last year, we'd run thousands of clients concurrently without issue, all executing attacks. I mentioned we've run a few game days recently preparing for launch and testing that we can handle when Dynamo gets slow or fails or other similar things. But we also, we have another load test scheduled for next week where we're going to be throwing, again, thousands to tens of thousands of clients at the service to make sure that it's ready for our customers and that it will scale.
One question I had is about the actual client, because you physically install a client on each of the containers or the AMIs that are out there, or are bare metal. Is there any overhead? How much resources does that client consume on what it's installed with?
Yeah, I think the binary itself is 25 megabytes. So it's fairly succinct. While we're not taking any action, we're trying very hard to do nothing on this system. Our goal is that we should be invisible unless we're causing an impact, and then it should be blatantly obvious. So the way that we pull, the way that we manage things in the background, it's very flat. There's no discernible overhead or impact to your systems unless you're executing an experiment.
Well, very cool. Thanks for talking a bit about Gremlin. So you've been doing a bunch of things recently around just supporting the community. I think you've done a white paper and you've got a Slack channel. Can you talk a bit about some of the things that you're doing around those areas and why?
Yeah, what I'd say is, and we saw this at our time at Amazon and Netflix too, more than just building a good tool, you have to build culture around it. You've got to build community. You've got to teach people. And so a lot of our focus this year and this coming year is just teaching the industry about chaos engineering, what we've learned doing it in the past, how to be successful. Obviously, if we can't help our customers have a more resilient service and prove our value, we won't be around in days to come. And so we have this vested interest in helping ensure everyone's successful, whether they're using Gremlin or not. So as you mentioned, we have a publicly available Slack channel that we built just to allow people to come and ask questions and share information. It's on a tiny URL. It's tinyurl/chaoseng. So anyone's welcome to come and join and ask us what we've learned. As you mentioned, we're putting together some white papers. We've just got one on kind of what is chaos engineering, kind of focused on the executives or the higher ups that may not be feeling the pain of carrying the pager. They may not be involved in each incident. And so to them, it may be a little bit more of a distant message, but really outlining these important concepts, the cost of downtime, the operational burden, the burnout that the engineers are feeling, and helping them to understand that akin to other things that are important that they're working on, chaos engineering will save them money because they're losing time, money, and good engineers to this operational burden.
Yeah, I'll tell you, that's probably something really interesting is learning how to talk to the executives is one of the challenges, right? Whenever you're trying to do something like this. So you mentioned something in particular, the cost of downtime, that I've heard many times being one of the things that really resonates when you're talking to kind of the C-suite. Can you talk a bit about what you mean when you say cost of downtime?
Yeah. So to start, there's a couple metrics out there that I tend to refer to. IHS Markit did a survey and they estimated that North American companies are losing $700 billion due to outages every year. There's another good study out there. I know PagerDuty spoke about it as well, but the cost of downtime being $5,000 a minute or $300,000 an hour. And I think that's a lower bound. From my time at Amazon, I will tell you, if an e-commerce site happens to go down on Black Friday, and you can Google these numbers, it's tens of thousands to hundreds of thousands of dollars a minute. And so, really driving home that every time there's an outage, not only are your customers losing faith in you and your brand is impacted, not only do you have engineers that both have to get paged, triage, root cause, follow up, fix, mitigate, and then make sure that you're resilient moving forward. Kind of like the iceberg. A lot of people, I think about the outage itself, but there's much more time that goes into it after the fact, ensuring that it's understood and prevented. And then there's just the money lost because you can't do business. If your website's down, if you're a business who's relies on interacting with your customers over the internet and you're not available, you can't make money.
Well, Kolton, this feels like we came full circle from the first podcast to this one, talking about Gremlin and kind of bringing it all the way around. Congratulations on the launch.
Thank you very much.
And thank you very much for taking the time to chat with us. If you want to know more about Gremlin, check them out at gremlin.com.